and everything. Yeah, me too. Okay, so uh first problem, I take a look at this and I say, is it side angle side or side side side? And it is not either of those things. So it is law of sides. So if you guys could draw the arrows, so this goes with this. Yeah. And this goes with this. And luckily it says find BC. So I'm gonna put an X there between B and C. It's gonna come back to you. It's gonna happen. I actually feel weird writing. I don't know about you. Sine 54 over 34 equals sine 18 over X. Do you remember that part? Sine of the angle over the side across. Wait, check the thing. I reprinted it. Cross multiply. Divide. Calculator says round to nearest 10, so that's going to be 13. Okay, number 3. This one is side angle side. Side angle side is law of cosines. It's telling us to find BC, which is good. That's the side across from the angle we have. And when you do law of cosines, you want to start with that. So x squared equals side squared plus side squared minus 2 times side cosine of the angle between. Type it in one swoop. And then square root both sides. 33.5. That's I can't write, apparently. I don't know what's happening. It might be the fact that I think that this was about the time that I got up yesterday and the 2 weeks before that. It's fine. I also couldn't sleep last night. I don't know why. I slept totally fine all through break. Couldn't sleep last night. My brain was just not turning on. Anyway, okay, so we are using the packet for most of our classwork today, so do not put it away. We're actually going to start with you just watching me do something on Desmos, though. So we're doing two problems. The second problem has 8 problems in it though. None of it is hard. It's sketching graphs off of Desmos. It's not a big deal. It's actually a perfect thing to do when we don't have any memory of anything. Uh, this chapter is about polynomials. This is your homework. It has 4 problems. Does this joke make sense? Okay, so pirates, when they call their parrots Polly, the pirate, and if you don't feed him, he doesn't get a meal. So Polly, no meal. I have a question. You know the guy from SpongeBob, the pirate dude? What? No, like the real life pirate dude that's like super annoying. What's his parrot's name? Nobody? Nobody? I think it's Potty, which is just not good. Okay, so if you guys could just chill for a moment and just watch me do some business on Desmos, so you can save yourself the awkward writing for a few minutes. Okay. Number 1, the Math America Land Carnival Company has decided to build a new roller coaster to use at this year's county fair. The new coaster will have a very special feature. Part of the ride will be underground. The designers will use the polynomial functions to describe different pieces of the track. Part of the design is shown at right. Your task is to guess a possible equation to represent the track and test it on your graphing calculator. To help get an idea of what to try, start by checking the graphs of the equations given below. Think about how the graphs are the same and how they're different. Okay, you don't have to do this on your graphing calculator. I'm just going to do it for you with Desmos because I don't know, we're lazy and it's time. And anyway, okay. So I already typed this first one in right here, the top one. Your job is to see if it looks like this roller coaster. Could you just take a look at the roller coaster over here? And then I'm going to show you Desmos, and I want you to tell me if it's the same thing. No. Okay. Is part of it the same thing? It is. So it's coming down here through 0. That part's the same. Okay. So 0, 0 right there, 0, 0 right here, and it's coming down through there. And that one goes back up through 2, but it just goes forever. Okay. So now I'm going to add a squared on it. I want you to see, is this the same thing? No, it's closer. Yeah, so it's flipped, first of all. There's this situation here, which is better. Okay, and then what else did it tell us to try? X minus 2, x minus 3. So take off the squared. Is this the same thing? Okay. Since we're all too tired to guess what I need to do, I'm just going to do what I need to do, which is take that squared and put it back in. Now, is this your roller coaster? Yeah. You're my favorite. Okay. So if you guys could take your notebook, and this is all we're putting in the notebook today, just this little tiny bit. Okay, now we're gonna do this problem backwards. And I know that that's strange, but uh, this is what we're gonna do. So I want you guys to come over here. And what we're gonna do first is multiply this out. You're gonna be very upset about the amount of work that that takes, but it's okay. We got this. I want you to start with the x minus 2 squared. Okay, I'll pause here because we're all half asleep. Does my answer make sense for what I did? So I took that x minus 2 squared, put it in a box, combined like terms, and then just change that middle part. Does that make sense? You sure? Okay, now I'm going to do a 6 box with these two. Thanks. You did? It wasn't in a bun? I thought it was in a man bun. Why would he do that? I mean, okay. Well, that was just an interesting thing to say. I just wasn't expecting you to say that. 8:47 a.m. first day back. I don't know. I don't really do. I don't know about that. I do like his hair. And the effort he puts into his outfits, I can't do that anymore. He's young, so you know. Okay. We have x cubed minus 4x squared, 4x negative 3x squared. I feel like I'm going to mess this up. 12x minus 12. Okay, and then what's the last step here? Yeah, distribute the x, yeah. Okay, by the end of this chapter, this is my goal for this chapter is for you to be able to go from here to here. So we're going to be in this chapter factoring things that are not quadratic. And so it's just going to be the backwards of the box and it's not a big deal. I promise you. It's like one of my favorite things. But we all know how to go this direction. By the end of chapter 8, you'll be able to go that direction. Anyway, okay, so very important thing. So the rest of this problem is all vocab. First, this is called factored form. Factored form has the parentheses. Can you tell that this has been factored? Somebody factored it. We're very excited about the fact they did that for us. Okay, this is called standard form. They have their pros and cons. Okay, we're going to go backwards to, believe it or not, on this list of things. We're going to start with the degree. The degree of this polynomial is 4. Anybody want to guess where the 4 came from? No, it's the x to the 4th. Yeah. Okay, so the degree is the highest exponent when it's in standard form. Okay, now I multiplied this out, but I want to show you how to get the degree from the factored form because I don't want you to have to do this every time. Because if somebody factored it for you, why would you go back to standard form if you didn't have to, right? I did this to prove a point. I wanted to show you that this was an x to the 4th problem. But this is also an x to the 4th problem. How can I get x to the 4th from this without doing all this work? Count, exactly. So there's a 1 here. There's 2 here. Do you see why there's 2? Because it's squared. And then there's 1 here, x to the 4th. So this would be an x to the 4th, which would give me degree 4. So I want you to be able to do that from standard form, just looking at the highest exponent. And I want you to be able to do it from factored form, just counting the x's. Okay, now factors. This particular problem has 3 factors. One of the factors is x. One of the factors is x minus 2 squared. And one of the factors is x minus 3. Factors are things that multiply together. And so we squish them all together like glue and put them like that. Okay, does everybody see where my factors came from? Okay, now we're going to go backwards to roots, zeros, and solutions. Roots, zeros, and solutions are all the same thing. They're all interchangeable vocab words, which is really annoying because if I say roots and you say solutions, we're saying the same thing. This is the solution that has to do with the x. This is the solution that has to do with the 2. This is the solution that has to do with the 3. This is the same thing as zero product property when you factor and then you get x equals. Okay, however, there's something special. Because this one is squared, we call it a double. I'm going to go back to that in a second in the graph. Okay, and then the x-intercepts, what you do is you take the roots, zeros, or solutions, and you just turn those into coordinates. So this one is 0, 0. This one is 2, 0. And this one is 3, 0. And that 2, 0 is a double. Can you guys all tell why it's a double from the equation? Because there's 2 of them, right? Because of the squared. Okay, now let's go back to the graph real quick and look at what happens.
3 0 would be a triple.
No, that's a single.
Oh, is that what it's cubed?
Yes, if it was cubed, it would be a triple, and that is a thing, and we're going to talk about that in a minute. Okay, I want you guys to look at the graph at 2. I want you to see what happens when you have a double, when you have a squared on one of your factors. It bounces off the x-axis. So it doesn't cross it. So each of the single ones, I call this a pass-through. passes through the x-axis at 0, that was a single one. Passes through the x-axis at 3, that was a single one, but because the other one had a squared on it, it bounces. What you want to think about, this is going to be my first bit of talking about calculus in here, is you're approaching it from both sides. So you're getting a 2 from that direction and a 2 from that direction. It's a limit as it approaches 2. And you're getting going towards 0 from one way, going towards 0 from the other way, and that's why it counts as 2 things. So anyway, if you guys could just remember that if it's squared, it makes a bounce on the x-axis, that would be great. Okay, now find that resource page, please.
You say, oh, it's nothing that is started in last semester.
I always say that math builds on itself.
Oh, so you have no idea. Oh, yeah.
I don't know.
Smart people want to advantage and advantage of business for the company.
Um, it's different because a lot of people like figure out how the class works as time goes on and their grade just improves over time. Because they figure out how to kind of do it. So there's that too.
You can kind of cook.
I don't think you're cooked. Do I think you can cook? Yes. Okay, anyway.
Thank you.
Okay. So we're gonna look at number 1. We're gonna do this one together. We're gonna answer some of this stuff, then we're gonna make a sketch here off of Desmos, and then we're going to just finish it up. I'm gonna do a couple of these with you, and then I'm gonna have you guys get your Chromebooks out and finish it as much as you can. These should not take you very long. If it takes you a long time, you're doing it wrong. Okay, first, what is the degree? 3. And I have 1 here and 2 here for a total of 3. Okay, why is this important? It's important because that means there should be 3 roots. This is the fundamental theorem of algebra. Fundamental theorem of algebra says the degree should match the number of roots. That's how you know how many answers you should have. Okay, so I can tell my roots are at x equals 2 and x equals -5. And that one's going to be a double, which should look like a bounce off the x-axis. Are you guys with me so far? Okay, great. Okay, so now I'm going to go. I think I did that the most non-efficient way possible. Okay, when you guys are doing this, you might have to zoom in and out. And please don't worry about the size of the loops. We're just sketching today. That's it. So notice if I zoom in here, I'm getting that bounce that I was talking about at -5. And then I have a pass through at 2. So you're going to do 2 -5. We're just going to sketch in the general shape. Please do not worry about being perfect. Notice we didn't even scale the y-axis on purpose. Okay, and then end behavior. Left arrow's going down, right arrow's going up. Left arrow's going down, right arrow's going up. So that's about how long that should take. It's not a big deal. Okay, can you guys move down to number 3, please? Okay, number three. What is the degree of this one? 4. Yeah, so standard form, the degree comes from the highest exponent.
All right.
It's why I wanted to talk about it. It's all good. Okay. That means that there should be 4 roots. Unfortunately, this is in standard form, so we can't see them. But what we can do is cheat off of Desmos. Okay. So, which is why I wanted to do this one with you. X to the 4 something minus 21x squared plus 20x. Okay.
Oh.
It's okay. Just plot these first. So we have -5, 0, 1, and 4. -5, 0, 1, and 4. Okay, then there's your picture. So just sketch that in. Notice the like bottom bump over here is like lower than the one on this side. Makes like a W type shape, but lopsided. I don't. Okay, so the roots were -5, 0, 1, and 4, and they were all single. And you can tell they're all single also because there should be 4 of them because it's degree 4, so that should match. And then what I can do if I want to is I can cheat off of Desmos and rewrite this in a factored form. Do you see where I got the factored form from? So the x, plain x comes from the 0. And I put that in front because of just that's how we write mathematical etiquette. So plain x would go in the front. Then this would be the opposite sign, opposite sign, opposite sign. And the order of these things does not matter. Okay, end behavior, positive, positive. Okay, last one I want to talk about is, I think, number 5. Yes, number 5. You guys can find number 5. Okay, this is the last one we're going to do together, and then I'm going to let you finish this with your Chromebooks and your own Desmos. Um, Question, what is the degree of this one? It's 4, yeah. So you do not use this decimal as part of the degree. That's the A value. That's the stretch factor. So this is your stretch. And there's your 1, 2, 3, 4. So 1, 2, 3, 4, degree 4. Okay, what are the roots? We have one at 0, and we have one at -4, which is a triple. Which is the reason I wanted to do this one together because we haven't done a triple yet. I'm just going to throw A equals -0.1 up on the top there so that I can tell that's not part of finding the roots or the degree. It's just my stretch factor. Okay. So if you guys could plot this and this. So plot me what happened? Plot me a point at -4 and 0. And I want you to see the triple root. Triple root is a squiggle. Do you guys remember when we did cubics? What's the vocab word for the yes, you already know. Inflection point. So a triple root is an inflection point, which is a squiggle. So you guys are so smart. No one's getting that today. No one else, just so you know. Bless their hearts. I love them. Okay, so what you're going to do is you're going to come up here and you're going to flatten out. Do it kind of like exaggerated. So come up here and then flatten out and then go back up. So that's a triple root. And it should look like an inflection point, like a cubic when we made a cubic back in the past. And then negative, negative. If you want, real quick, I can show you. Here's like this is my last year's one, but this is the inflection point for a cubic. It should look like that for a triple root. Okay, so you guys have the rest of the period to finish this. No, there's
Or like that's
the rest of these graphs.
like.
It really shouldn't. There's 5 of them. Yeah, but work together. It should not take very long. Really, it shouldn't. The hardest part is going to be typing them into Desmos.
Yeah. That's so hard to follow.
I don't even remember. I don't think any of them are hard, honestly.